Hey guys, welcome back to another video. I apologize for the long hiatus. I have been working, however, on a new system with Phil from Airborne Arms to bring the 34 grain pellet and 25 caliber up to speed in the R3 and R3M. So a little bit of background and some history. The 25 grain pellet has been the gold standard in 25 caliber guns for a long time. JSB brought that pellet to market, and most manufacturers, or several manufacturers, introduced guns that could shoot them relatively well, the Edgun being one of the best. It shoots that, if you own an Edgun Matador, you understand how well it shoots the 25 grain pellet. As soon as the 34 grain pellet came out a couple years ago, the question has always been, well, how do I get this 34 grain pellet to shoot well in the gun? And the answer has always been, you can't. And it's not because of the barrel, but it's because of the system itself. When Ed designed this gun, he obviously designed it with the 25 grain pellet in mind. And so the entire system itself was never designed to really bring what you need is about 65 to 68 foot-pounds to really make the 34 grain pellet sing. So Phil and I had this discussion, and it's been something that Airborne Arms has wanted to do for a long time. And we decided to try it with the Huma air regulator. And when I take this gun apart, you'll understand why the Huma air regulator works well in this system. But before we do that, let's go ahead and look at the difference between the 34 grain and 25 grain, and I'll explain to you why you may want to shoot this pellet at long range. So let's go ahead at this point and take a look at it. Okay, so what you're looking at here are the 225 caliber pellets that are offered from JSB and Edgun branded JSBs. The one on the left is the 25 grain pellet, and the one on the right is the 34 grain pellet. You can see that not only is the 34 grain a little bit taller and longer, that the punch in the rear is different. Now, the big thing to remember is I was thinking about getting all into ballistic coefficient and explaining it all, but then I thought it might get boring and people just fast forward it anyways and want to see the shooting part of it. So I'm going to keep it really simple. The sectional density of the 34 grain is going to be better because it's the same diameter with a little bit more weight. It's pretty as simple as that. The form factor is slightly better because it's a little bit longer and it's going to fly better. Plus that extra weight, if you can bring it up to speed, is going to carry its energy better downrange. All this means is that it bucks the wind better, the 34 grain I mean. It's going to hit targets harder. Obviously it carries more mass. And it's going to drop a little bit less because of its inertia. It's going to keep going. Its ballistic coefficient is going to be slightly higher than the 25 grain pellet. The holy grail has been to be able to push these things at 900 to 950 feet per second and be able to get almost 30 caliber performance out of a 25 caliber gun. And with this new system, we've been able to achieve that. So let's go ahead and take a look at the gun, the system, and explain to you how to modify your existing gun, or you can order a new gun with the new system in it. Okay, so before I show you the new system, I want to address a frequently asked question I get, and that is, what kind of wrenches do I use to take apart the Matador? I most often use Hoodie brand hex wrenches. The Hoodie brand are originally designed for RC cars. They're CNC'd and made of special tool steel, made in Europe. The ends are squared, so they will grab the corners of the small hex heads, especially the small metric ones, and you're able to torque on them. So you have a stubborn screw that you can't get out with a regular wrench. The Hoodie will grab it and not strip the screw head. So I think they're a good investment if you're going to work on your own air gun, and I highly recommend them. Okay, so I want to address one safety message before we get started, and that is, please make sure that your air tube is degassed all the way. I highly recommend using a degassing tool to perform this task. One thing that you have to remember is that you can never rely on the gauge. You always have to check the valve. And when you start to pull the screws apart, if you have any resistance at all on the screw heads, then you still have air in the tube. As you can see here, as I start to take apart this hex head, that there's almost no resistance. I'm just literally using my fingertips to remove the screw. You'll feel some resistance, and if you do feel the resistance there, you need to go back and recheck the valve. You'll most noticeably feel it on the last screw. As you lift the head out of the air tube and the threads are exposed, you'll feel the regulator body start pushing on the screw. If you feel that, stop immediately and take your degassing tool and open the valve up again, just to make sure all the air is out. It only takes a little bit of air to send the entire regulator, plenum, and valve body along with your degassing tool flying, and it can be extremely dangerous. Okay, so looking at the difference between the Edgun regulator and the Huma air regulator, you can see that there's a lot less displacement in the air tube. This entire piece here is the regulator, as I showed you, with the pistons inside. Now, all these pistons do is take up the free space that could be used to help push your pellet. Okay, so looking at all three parts here, this is the Huma air regulator. This is the Edgun regulator, which normally has the piston and all these neat little washers here. And this piece here is what we're going to name the power plenum, or the plenum extension. So what we're going to essentially do is take out all the guts here that would be normally found in an Edgun regulator, and we're going to make this power plenum extension here. As you can see, it's just basically a hollow tube. And what's going to happen is this tube right here, which I believe is about 5 cc's, is going to add that much volume to the overall plenum. Okay, so let's go ahead and take a look at the components of the power plenum. What you have on top here is the Huma air regulator. It's a low profile regulator which allows you to add this plenum extension, which would normally be the Edgun piston housing. You have the standard Edgun Matador plenum, and then the valve housing with the valve return spring. And one thing I wanted to show you on the valve housing and return spring, excuse me, the valve housing, is that I know that some of you might be concerned about bending valves or mushrooming the end of the valve stem, as the problem that was commonly found in the Generation 2 30 caliber with the 500 grain hammer. This system is slightly different in that the hammer is weighted in a different spot. So you're not going to have any issues with bending valves or breaking valves. Now currently I have approximately 3,500 rounds on this valve right here, and as you can see, it slides through just perfectly. There's no bending, there's no binding, and the end of it, as you can see here as I zoom in, is not mushroomed at all. The reason why this is like that is, number one, Ed did redesign the Matador valve. It's shorter and stiffer, so you're not going to probably break the Delrin portion of it. Also, the valve stem is not as long as it used to be because there's actually a recess in the valve housing right here. So that makes the stem a little bit shorter, so it's stiffer. But the big reason why you don't have to worry about bending a valve comes from where the weight sits in the hammer. As you can see here, the weight is directly behind the point of contact for the valve. So there's no shear force that's being placed on the edge of the valve, which is going to bend the valve up or down depending on where the shear force is. So that's one of the neat things about this system, is that you don't really have to worry about bending a valve or breaking it. And I have turned the regulator all the way up to 170 on this and all the way down to 120. I've had several hundred shots at each regulator setting, looking for the best setting for the best speed, and every time I took it apart and inspected it, there was no problem. So hopefully that gives you confidence in the system. The hammer weight is provided with the kit in order to give the hammer a little bit more mass, which in turn will give you a little bit more inertia. Remember that the gun was initially designed to shoot 25 grain pellets, so Ed designed the hammer weight, hammer spring, and pressure against the valve to all work together. These things all working together give you the proper volume to push the pellet at speed. And in air gun lingo, we call that valve dwell time. The longer that valve stays open, the more of the volume of the plenum is exhausted through the transfer port. And so we're all talking about the same thing. This is the transfer port. So remember, this part's the plenum. The longer this valve stays open, the more air exhausts out of the plenum through the transfer port, and gives you the proper amount of volume to send your pellet downrange at the speed that you want. So you have two choices when deciding how much valve dwell time to initiate in your system. Choice one is to crank the hammer spring tensioner up and smack that valve as hard as you can, providing enough force to open the valve for the proper amount of time in order to get the volume of air out of the plenum. That's choice number one. That is a bad choice. Choice number two is to match your valve dwell time with the weight of the hammer. What this does is allows you to actually use a little less hammer spring tension, get a little bit more force and inertia out of the hammer without really damaging the system. So the hammer weight is the key to the system. Your hammer weight when the system comes from Huma Air is going to look a little different. This is Phil's personal prototype that he sent me to test. So it's going to be a little bit different, but I can tell you that it works extremely well. Let's go ahead and put the gun back together, throw it on a chronograph, and then we're going to go to the range. I'm going to do a little quick range time. I'm not going to bother with 50 yards. We're going to go straight to 100 and 200 yard on paper, and we're going to see if we can get MOA at 200 yards. Alright, so before I start with the power plenum modification and show you what that thing is potential, I figured I would show you what the gun does in a standard Matador without the modification. So the first test here is going to be the 25 grain pellet to show you what it shoots in a standard Matador unmodified. This is what the standard Matador shoots with the 34 grain heavy. Okay, so now we have the Edgun Matador Long with the power plenum installed, set at 130 bar on the regulator with the hammer weight, and we are going to shoot the 34 grain pellets. Okay, so we saw the gun set at 130 bar, which hit right around 890 to 896 feet per second. And so now I'm going to show you what the gun will do at 140 bar. Again, like I said before, when the production model of the power plenum comes out, it's going to have a little bit more power than what my prototype model has, because the weight's going to be more in the hammer, and the plenum is going to have slightly larger volume because the plenum itself will be CNC'd instead of turned on a lathe. So you can most likely reduce 5 bar from what you're seeing in this test. So this is 140 bar. On your gun in the production model, you're going to be looking at probably 135 bar on the regulator. So let's go ahead and see what it can do here. I'm able to get it 130 bar, 890 feet per second pretty easily. If you turn it up to 135 bar, it's well over 900 feet per second. At 140 bar, I was able to get 950, 960 feet per second out of this system. For my personal gun, 890 to 900 feet per second is what seemed to shoot the best. So that's where I ended up leaving it, which was right at 130 bar for my gun. Okay, so now we're going to take a look at the 200-yard group that you saw on film. Here's the 4-shot group that I shot at 200 yards. This shot here was my wind dope. So let's go ahead and take a look at center to center, the 4 shots. These two are 1.32 inches. And the furthest center to center is 1.69 inches. And if I were to take the center of all these groups here, they'll fit inside 1.69. Just to jog your memory, minute of angle, or shooter's minute of angle, is approximately 2 inches. So this is a sub 4-shot MOA group at 200 yards. So I'm really impressed with the 34 grain pellet in the Edgun Matador. Seems like all I had to do was get it up to speed, and this is a viable group for hunting out to 200 yards. Let's see how the pellet performs in a little heavier wind with my next test. Just to give you a point of reference of the size of this group, that square in the middle is a 3.6 by 3.6 inch square. Wind always makes everything interesting, especially at long range. You can see the wind making that pellet walk. On my way out to pick up my target, I saw this KTM clutch cover hanging from a tree with a string. So I thought it'd be interesting to try to gong it a couple times at 200 yards. As you can see, the wind kept spinning it, so it was going to make for an interesting shot. I thought it'd be fun to see the kind of power that the 34 grain had at 200 yards. I'd like to take this opportunity to thank Phil from Airborne Arms of New Zealand for all his knowledge, support, and machining ability to help make this project a reality. Thanks again, Phil, and I hope you guys enjoy the new system. Okay, so I'm going to go ahead and do my shot string, and if you hear whining in the background or a little crying, it's her fault. She's a hunting dog, and she doesn't understand that when I shoot, it's not always resulting in something for her to go fetch. So if you hear some background noise, you can blame her.